Now I'm going to go over the anticipation guide that you worked on from the last video after reading section 1.2. And hopefully you kind of were getting the hang of this as you were going through it. So I want to go over each statement individually and go over a couple of places where I found some information in the textbook that supports whether this is a true or a false statement. So for number one, the statement, chlorophyll makes grass green, is a scientific hypothesis. I would say that that statement is true. So you could test it by extracting chlorophyll. But if I'm looking for things that there's information to support it in the text, if I go to page 10 in the first paragraph, if there is no test for its possible wrongness, then the hypothesis is not scientific. Albert Einstein put it well when he said, "No number of experiments can prove me right. A single experiment can prove me wrong." So this is truly the key statement about what scientific, as an adjective in this case, what it really means. So if there is no way to test that something is wrong, you cannot say that the hypothesis is a scientific hypothesis. It could still be a hypothesis, it's just not scientific. The other place that I found on this page that I believe is helpful is in the fourth paragraph. It starts with a hypothesis. A hypothesis that is capable of being proved right but not capable of being proved wrong is not a scientific hypothesis. Many such statements are quite reasonable and useful, but they lie outside the domain of science. So the statement chlorophyll makes grass green is scientific because you could test it. You could remove the chlorophyll and determine if it is still green or not. And it doesn't matter if this statement is true or false for what we're considering right now. What we are considering is there a test to show that it is wrong? And so that in this case, you should end up with a check mark next to number one. If you did not have this there, just write over what you had. It's okay to have an incorrect answer before you started, and that's why we're going over these. But don't change what you wrote before. You may have found other statements in the chapter that support your statement, or whether being true or not, but these are the ones that I found. Number two, the statement, Earth rotates about its axis because living things need an alternation of light and darkness, is a scientific hypothesis. I actually went to the exact same places, page 10, first paragraph, and page 10, fourth paragraph. So the same exact places. But there's really no way to prove this wrong. How can you stop the Earth from rotating about its axis? I don't know that there's any way of doing anything to try to help prove that that's a wrong statement. So in this case, this one is a false statement because there really is no way to prove that statement wrong. Number three, the statement tides are caused by the moon is a scientific hypothesis. Again, I'm actually going to use those same statements, page 10, first paragraph, and page 10, fourth paragraph. This one's a little trickier because we can actually prove this one wrong because you can actually look and see, do tides correspond to the position of the moon? And when the sun is between the moon and the earth, what's happening with the tides? What is happening with the tides when the moon is closest to earth as opposed to farther away from earth? And so by looking at what's happening with the tides, you can actually prove this to be right or wrong. So this one's a little different because you would try to think about, could you remove the moon from it? And that's not quite what happens here, because actually there is a correspondence between the tides and the moon, and you can see that. So this statement is truly a scientific hypothesis. Number four, success in science is linked to emphasis on experiments. So in page 9, the blue bubble, it says experiment, not philosophical discussion, decides what is correct in science. So again, experiment is important. Page 8, we've got a whole list of the scientific method where it talks about performing experiments to test predictions. Page 8, last paragraph, that starts with a scientific hypothesis. On the other hand, is an educated guess that is only presumed to be factual until it's supported by experiment. And page 9, paragraph 4, the very last sentence that says, better hypotheses are made by those who are honest in the face of experimental evidence. So this is a true statement, and there are a number of places in the section 1.2 that indicate that this is a true statement. Then number 5, more important than a test for proving a hypothesis right is a test for proving it wrong. So page 9, 5th paragraph, 1, 2, 3, 4, 5. And the third sentence that starts with the cardinal rule in science is that all hypotheses must be testable. They must be susceptible, at least in principle, to being shown wrong. In science, it is more important that there is a means of proving an idea wrong than a means of proving it right. This is a major fact that distinguishes science from non-science. At first, this may seem strange because when we wonder about most things, we concern ourselves with ways of finding out whether they are true. Scientific hypotheses are different. In fact, if you want to distinguish whether a hypothesis is scientific or not, check to see if there is a test for proving it wrong. If there is no test for its possible wrongness, then the hypothesis is not scientific. So in this case, it is very important that a hypothesis there's a test for proving it wrong, and that is what allows us to say if something's scientific or not. And then the last statement, number 6, a fact in science is forever true. So I looked at page 8, the last paragraph, first and second sentence. It is common to think of a fact as something that is unchanging and absolute, but in science, a fact is generally a close agreement by competent observers who make a series of observations about the same phenomena. And page 9, 4th paragraph, the theories of science are not fixed, rather they undergo change. Scientific theories evolve as they go through stages of redefinition and refinement. So a fact in science is not always forever true. Okay, as we continue to learn more and improve our understanding of science, we actually are learning that things that we've taught that were true before, we believed were true, are actually not. And one very good example about that is Copernicus, when he recognized and believed that the sun was the center of the universe instead of the earth. So prior to that, people had believed that everything revolved around the earth, and then he came up with the idea that no, that's not actually the case, that the sun was the center of the universe. So things that were held to be fact do change as we gain better understanding. So what I'm going to ask you to do now is to, actually I have a couple questions more to go over. Questions 12, 14, and 25. So question number 12 was, in daily life, people are often praised for maintaining some particular point of view, for the courage of their convictions, and a change of mind is seen as a sign of weakness. How is this different in science? Well, competent science must be able to change their mind. They must be able to have the thought that sometimes they could be wrong, and things that we always knew could have been wrong and are changing. Number 14. In daily life, we see many cases of people who are caught misrepresenting things and who soon thereafter are excused and accepted by their contemporaries. How is this different in science? So whereas mistakes or misrepresentations are given second chances in daily life, second chances are not given to scientists by the scientific community. If you make up data or you lie about things, people don't accept that. You don't want doctors and medical professionals lying about their work and treating you with things that don't actually help you but harm you. You want to believe about the safety of the vehicle that you're driving to and from school. So as far as the scientific community there are things, consequences to lying or misrepresenting things. And then question number 25. In answer to the question, when a plant grows, where does the material come from? Aristotle hypothesized by logic that all material came from the soil. Do you consider his hypothesis to be correct, incorrect, or partially correct? And what experiments do you propose to support your choice? So in reality, his hypothesis was partially correct. Plant material comes partly from the soil, but mainly from air and water. An experiment would be to weigh a pot of soil with a small seedling, then weigh the potted plant later after it has grown. The fact that the grown plant will weigh more is evidence that the plant is composed of more material than the soil offers. Keep a record of the weight of water used to water the plant and cover the soil with a plastic wrap to minimize evaporation losses, and then the weight of the grown plant can be compared with the weight of water it absorbed. So how can the weight of air be taken in by the plant be estimated? You can do pretty much the same thing by having it in a contained, closed environment.